CNT underscore season 3. Go to the day sheet, unclick season 3, click on season 4, Control Shift down arrow, Control C, Control V, CNT underscore season 4. So we have applied filter on season. We have applied filter on season and we have copied the CNT column. We have copied the CNT column of the season filter. CNT column, last column. First, unselect all, then click on season 1. You will get the CNT of season 1. Right side, you will get the CNT of only season 1. Control Shift down arrow, copy the column, paste it into the new sheet. Similarly, go to the day sheet, unclick season 1 and click on season 2. Then copy the CNT data, paste it into the new sheet. So like that, you have to apply filter and paste data like this. CNT season 1, CNT season 2, CNT season 3 and CNT season 4. Like how we have done yesterday. Apply filter on season. You have to apply filter on season and copy the CNT column. You are attending for the first time? Acha, online, okay. You have the sheet now, Excel sheet, open it. Apply filter on season. Yeah, Sneh, day after tomorrow interviews, mock interviews. Put it in the group, na? Each student, each person will have 20 minutes. You have to split the data. Calculate the mean of four columns. Calculate the mean of 4 columns.
Yes, sir. 1 minute.
Okay, 1 minute. Do it slowly. For the season, because the filter on next season. Okay. Now copy the CNT column. Last column. CNT. Control C down arrow. Control C. Go to the sheet. Paste it next here. CNT not there. Only mean. Only mean will be done. Calculate the mean of the 4 columns. So is equal to average. Oh, we have more. All of you got the data and averages of the 3 variables, 4 categorical variables. Season 1, season 2, season 3 and season 4. Season 1, season 2, season 3 and season 4. Now, Anova single factor manual calculation, the formula is very, very big. So Anova single factor, I think we'll take this only. So typically the Anova formula is very big. So you have to do all these calculations. Sum square within, sum square between, then the degrees of freedom, mean square within, mean square between, and then the F statistic. The F statistic which we get in Anova, in our Python, the F statistic is finally calculated. So the final value which we are getting here, this statistic calculation which you get here, 15.294, backend you have to do all these calculations. All these calculations have to be, so then only we will be able to get the F statistic. Then only we will get the F statistic. Once you get the F statistic, we will get the p-value, and based on the p-value, we will calculate the what we call null rejection or failed rejection of the hypothesis. So before we calculate these formulas, let us do the automated one in data analysis. So if you go to the data tab, and in data analysis, the first one, Anova single factor. In the data analysis, the first one is Anova single factor. Click OK. Click OK. Now, input range, you have to select all the variables, all the columns. Control Shift side arrow. So, data analysis, Anova single factor. OK. Why it is not moving? Tell me why it is not moving. Okay. Data analysis, Anova single factor. So select the complete data range, including the empty cells. See, bottom you will also have to select the empty cells for some columns. Complete data range you have to select. For the longest column, you have to select the complete data range. Tick mark labels in first row, output range, and select some empty cells. Select some empty cells and click OK. You will get the Anova value. So we got F as 128. So let me check Python if we got the same value for the test. Yes, 128.76. We got exactly the same value in Python. So Anova single factor, the first function in data analysis, select the complete data range, then tick marks labels in first row, then select some empty cells and click OK. That means you missed some rows. Select complete data range. select some complete data range till the last value of the data, because one column is very large, the other three are long. So scroll down and see whether you are selecting the complete range or not. You have to select till 189 row. All right, all of you got the output. So this process is very complicated. In Excel and Python, we get the direct answer. But if you are doing a manual calculation, or the actual calculation is quite complex. So first we need to calculate x minus mean whole square. We need to calculate x minus mean whole square of all the three columns. And then we have to calculate, I will show you the is equal to open bracket x minus mean. We have to fix the mean to the power of 2 is equal to open bracket x minus to the power of 2 is equal to x minus equal to sum of. See, this is the sum square between. You can see here, same value what we got here, sum square between. X minus mean whole square. For each column, you have to calculate x minus mean whole square. Then sum the x minus mean whole square. The sum total of these three is this. Then grand mean is mean of means is equal to, then SS within is equal to open bracket mean minus grand mean whole square plus open bracket mean minus grand mean whole square plus open bracket mean minus grand mean open bracket mean minus 95059 we got, but we got only 597 here. This is what we have found now within. Within, sorry. Between, why we are not getting, that's what I'm looking at. I'm making mistake somewhere. We got the grand mean. Acha, n into. We forgot the count. N into. There's some formula error. No need. Just to understand. 95059 5868. We got slightly above. 181, 184, 188, 178. We got the value correct only. Okay. So then we calculate the mean square, which is nothing but this 1779 divided by how many variables we have? No, we have to look at the variables, sorry. 16 variables. It says k minus 1 is 3. Okay, number of levels only. 4 minus 1, got 593 something, but he got 2, 4. Okay, this has to be 727 years. 128. So this is how we get the values. So this is a complex calculation. I will share the Excel sheet with you. You can look at it. Okay, just to understand how the Anova works. Okay, so we will get the same value what we got in Python. 128 F statistic, and these are the formulas. Only thing is it has to be n into x minus. So this is slight difference is there here. So we will get 128.784. Some marginal round of errors are coming, but we are getting the same value. So this is the whole process of Anova calculation, which is there in thing. But in software, we'll just get the output. This whole process is done in the backend, but we'll get the output directly in software. Right? Anova single factor when there are more than 2 levels. Now, when both variables are categorical, or non-numeric, we have to do chi-square test of independence. When both variables are categorical, when both variables are non-numeric categorical, we have to do chi-square test of independence. The input of this test is cross tabulation. The input of the test is cross tabulation. Cross tabulation is frequency table of 2 non-numeric categorical variables. Cross tabulation is frequency table of 2 non-numeric categorical variables. The input is cross tabulation. The null hypothesis is no association both variables. Alternate hypothesis is same statement, remove the word no before. There is association between both variables. Null is no association, or some places we use the word relationship, and the inference is same p-value based inference. The inference is the same p-value based. Test null, no association. Holiday, test null, no association between holiday and season. PD dot crosstab bike data dot holiday, comma, bike data dot season. SciPy dot stats chi2 underscore contingency. Chi2 underscore contingency PD dot crosstab bike data dot holiday, comma, bike data dot p value is this. PD dot crosstab. That is the function for chi-square test. Every function needs to be imported. Until unless you import the function, you cannot use the function. Anova, one variable should be numeric, the other should be categorical. Here, both are categorical. So when both variables are non-numeric, we will be using chi-square test of independence. So in chi-square test of independence, the input is the cross tabulation. First, you need to create this cross tabulation. This cross tabulation is based on this, the expected table is calculated. And using this is the expected table which is calculated. Using these two tables, we will calculate the chi-square. Hey, give me the cross tabulation values. Holiday 0, S4. What are the values in cross tabulation? 170, 180, 172. So row total is this, column total is this. This is grand total. This is the grand total. This is the row totals. These are the column totals, and we have the grand total. So we have to create a table called expected table. Expected table is equal to row total multiplied by column total divided by. Now using this formula, we have to calculate the expected table. So I will copy the headers, just copy the headers. Now the first cell is equal to open bracket, row total multiplied by column total divided by. So row total I will fix it because I am going to drag formula horizontally, and grand total also you have to fix it by pressing F1 F4 because we are going to drag it horizontally. Now if you go to Python, you will get the same values. See, 175.80, 178.71. See, same values are getting it. So the formula we use to calculate the expected table is row total multiplied by column total is equal to open bracket, row total multiplied by column total divided by grand total. Since we are going to drag the formula horizontally, we will fix the row total and grand total by pressing Fn plus F4. Fn and F4. There is an Fn button on the left side of your laptop. Fn plus F4 will insert $2 signs. Same thing for the below one is equal to open bracket, row total multiplied by column total divided by, again we will fix the row total and grand, and we will drag it to the right. So this is the formula. Observed minus expected whole square divided by expected. The formula is observed minus expected. Observed table represented by O. This is the expected table represented by E. Chi-square, chi-statistic is equal to open bracket, observed minus expected to the power of 2 divided by expected plus open bracket, observed minus expected to the power of 2 divided by expected, open bracket, observed minus expected to the power of 2 divided by expected plus observed minus expected to the power of 2 divided by expected, observed minus expected to the power of 2 divided by expected plus open bracket, observed expected to the power of 2 divided by expected, open bracket, observed minus expected to the power of 2 divided by expected, observed minus expected to the power of 2 divided by expected. 1.496108. See, 1.496108. We got exactly the same value what we got in Python. Observed minus expected whole square. So this is how the chi-square statistic is calculated. This is one of the most frequent tests we do in data business also, because most of the time we see data as categorical. The chi-square test of independence is for categorical data. This is one of the common interview questions. How do you find relationship between two categorical variables? Relationship between two categorical variables can be found using chi-square test of independence. Relationship between two categorical variables is found using chi-square test of independence. How will you find relationship between two numeric variables? How will you find relationship between two numeric variables? How will you find relationship between two numeric variables? Correlation and covariance. Relationship between two numeric variables is correlation and covariance. Relationship between two categorical non-numeric variables is chi-square test of independence. This is one of the most common interview question you will find. Relationship between two non-numeric variables is chi-square. Relationship between two numeric is covariance and correlation. Now I'm just giving you the formula orientation so that you can understand. Not that you have to remember the formulas or not that you have to execute them in Excel. But you need to understand to be able to explain to the recruiter what is a chi-square test. They'll ask you what is a chi-square test. It is a test conducted on categorical data. Two categorical variables cross tabulation is used for calculation of chi-square test. It tells you the relationship between two non-numeric variables. Null is no association between both variables. Alternate is association between both variables. If you remember the formula, you can tell the formula. Sigma observed minus expected whole square divided by expected. Or even if you don't tell formula, you have to explain what that means. Okay, simple terms you have to explain. So the simple terms I am giving in the Python the notes. You just need to remember these notes. What is a chi-square test? See, in 3 lines I have given. This is what you have to tell. If they ask you what is a chi-square test, you have to tell what is written in this box. And if you remember the formula and you tell the formula, that is even better. Now, conduct this test. No association and weather situation. Weather sit. Conduct the test between season and weather situation. W ఇవ్వాలి 3,800. 3,800 ఇవ్వాలి బెడ్కి. ఆటో ఛార్జెస్ ఎంత అయితే అంత వాళ్ళు వేస్తారు. లోపలికి చేసారా బెడ్ పీడీ డాట్ క్రాస్ టాబ్ బైక్ డేటా డాట్ సీజన్ bike data dot weather situation. You got the cross tabulation, right? Try to underscore contingency. You can copy the cross tab function from top. This is the p value. P value is equal to 0.05. We will reject null. That means there is a relationship between season and weather situation. There is a relationship between season and weather situation. Season and weather situation, there is a relationship. Done. So when you have non-numeric variables, categorical variables, the test we will do is chi-square test. One more test we do is paired sample, also called as related sample t-test. Paired sample t-test or related sample t-test. Data is in the form of and after, before and after an event. The blood pressure of the patient before he took the tablet, blood pressure of the same patient after taking the tablet. In this test, one entity will give you 2 data points at 2 time intervals, before and after. You will get 2 data points called before and after an event. Blood pressure of the patient before taking the tablet, blood pressure of the same patient after taking the tablet. Here, one patient is giving us 2 data points, before and after. So when your data is before and after, then we have to use the test called paired sample t-test. Before launching the Facebook campaign, what was your sales? After launching the Facebook campaign, what was your sales? Before Facebook campaign, after Facebook campaign, what is your sales? To know whether the Facebook campaign is successful or not. Okay. So the paid sample t-test is used when you have the scenario of before and after. So paid t-test, this is the formula by square root of n into sigma d square minus sigma d whole square divided by n minus 1. Paid t-test formula. So when your data is in before and after format. Take for example, so November 2016, we had demonetization. Remember, November 2016, we had demonetization. Before demon, what was your India's inflation, monthly inflation of India? Before demonetization, what was the monthly inflation? 3.35, 4.14, 5.30, 6.46, 6.13, 6.59, 5.86, 5.51, 5.53, 5.91. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need 2 more months. 6.32, 6.72. 12 months before. After demonetization, inflation values. November is 2.59, 2.23, then 2017, 1.86, 2.62, 2.61, 2.21, 1.09, 1.08, 1.79, 2.52, 2.89, 3.24. Consumer price inflation before and after demonetization. Before and after demonetization, these are the values. So average is before demonetization is 5.61, 65. After demonetization, the average is 2.22. Before and after. From scipy.stats t-test underscore rel. T-test underscore rel before demon, comma, after demon. P-value less than 0.05, we will reject the null. Calling from? You're calling from which bank? No, I don't have a salary slip. I don't have a salary slip. So this is before GST and after GST values. GST was implemented in 2017 July. In 2017 July, GST was implemented. CPI 12 months before GST implementation, before and after GST, before GST, after GST and before GST. Conduct the test and then fail to reject null. Confidence is different. Confidence is how sure your statement is correct or wrong. P-value is related to whether you are rejecting or fail to reject the null. That is not related to confidence. Confidence is how confident you are on the hypothesis statement. See, take for example, India versus Australia. Whom do you think you will win? 100% India only? No, right? You will have certain amount of confidence level. Say 70% India, 30% Australia. You will take last 100 matches scores of each of the tests, do a test, and you will come to know whether Australia is better or India is better. The difference, mean difference is significant or not, you will come to know. In the mean significance, if India has higher mean, we will assume India will win. If the Australia has higher mean, we assume Australia will. So there is always a confidence level. You cannot be 100%. Typically, 50% is what we generally go as confidence level. 50-50 chances will give. If you are too much confident, you will go up to 90%. See, even India, Bangladesh, you will give Bangladesh 10% chance, right? Because they have defeated us. They have defeated earlier. If they have not defeated India earlier, then you can say 100% India will win. But there is a historical proof that Bangladesh has defeated India. That means you have to give them certain amount of. So this is what happens here. 95% only you can give confidence. Rest of the 5% you don't know. Anything can happen. Unknown variables will be there, right? See, no matter how much we try to make decisions with data, we still go wrong. We still go wrong. Now, why we will still go wrong? Because of other factors which are not under our. Take for example, share market. One of the most profitable companies in India, but its share price is falling. Technically, if a company is in good profits, the share price should. It has very stable CEO. It is part of Tata Group. Very good company. No frauds. Nothing. It's a very good company. They have very good customers. They have very good client. Large number of employees. Everything is good. But still the share falls. Why it falls? Sentiment, which we cannot consider in our numerical data points. How will I say this is a good company? Based on data points, their profitability, their revenues, their number of clients, their client feedback, employee feedback, all these things are numerical data we can get. but still the share price will go down. Why? Because of the unknown factors or because of unknown sentiments which cannot be captured by this data points. So always remember there will be factors which will affect your decision despite you making a right decision. Despite you have made a right decision. You have made all correct decisions using the data analysis, but still it may not work because there is always something which will unknown, like COVID. Before anybody thought will COVID happen? And anybody thought there will be 1 month lockdown and everything will be shut down? And did anybody thought companies like Google, Microsoft, Facebook, which have billions and billions of dollars of profits, billions and billions of dollars of cash with them, still lay off people? People never imagined. 3 years back, if you had said Google will lay off people, because Google is the most profitable company in the world, they have billions of dollars as cash. They can simply give employees salaries for next 10 years without any work also. That much cash they have. But still they are laying off people. Huge company with so much of profitability and revenues and cash, they are laying off people. Facebook. So these companies are not small companies. They are in profit. They are not in losses. They are in very, very high profitability. They are monopoly companies. In their business, nobody is competition to them. They make billions of dollars of money and cash. They have cash. Bill Gates has so much of cash. He just keeps on giving in non-profit. But still they are laying off people. So we can't be sure what will happen when things will change. We can't be sure. So to that uncertainty, we have to leave that 5%. You cannot be 100% sure. You should leave some amount of error rate, 5%. Probable that my judgment is wrong, or probability that test is wrong.
We calculate the p-value again.
Compare it, not calculate it. Compare it. 0.05 is a comparison metric, not calculation metric. We never use it in calculation. We compare it with 0.05. You can compare it with 0.01. You can compare it with 0.10 also. 90%. It's a comparison metric.
The value is decided by decision maker.
You can choose your own metric. The comparison metric, whether it is should be 0.10 or 0.05 or 0.01 will depend on the business. It depends on the business, and business will decide what should be the confidence levels.
And this ultimately means that 0.05 is the confidence.
Yes, that's what, no? We don't talk about 0.05. We'll say 95% confidence level. See, we talk in terms of confidence levels. I am 95% confidence that this test is right. What this test is telling us, GST did not affect the inflation. Whereas demonetization has affected the inflation, GST did not affect the. So these are the decisions you have to make. See, you promote any person hoping that guy will do well, but still we have instances where they fail. I have personally seen. We promote people, he's a good worker, we promote him to assistant manager. After 1 year, his performance will be very bad. So we think we make decisions based on the data available. He worked very well for 5 years, so we promoted him. But upon promotion, his performance went. So we can't blame ourselves, right? So it has to be based on data we have promoted, but it didn't work. So same thing happens. So we make decisions on data, but sometimes those decisions will fail. Why they fail? Because of reasons which are not in under our. So that is what is happening. So a lot of people are saying Amazon has a lot of money. Google has a lot of money. Why they are laying off people? They said we have to lay off people because that is what business shareholders want. We can't give simply salaries and keep them because again tomorrow investors will complain that you are simply giving money to people without making them work. So they have to restructure their business. Despite their ability to give money to the people and keep them idle also, they still don't want to do it. They are ethical companies, they don't want to do it. Whereas in India, we can put them on bench, give them free salary for 6 months, 1 year. But American companies don't think like that. They say, even though we have cash, we will not feed them. We will just remove them from our roles. They are very powerful company, Tesla and all these companies. So that is the things which will happen. So you always have to have some percentage of confidence for unrelated or unexpected events. There will be always unexpected events. There will be unexpected events. So we have to leave certain amount of. That is why in statistics we say there is no 100%. In statistics there is no 100%. It is only 95% or 99% max. There is no 100% in statistics. Same thing adopted by data science and machine learning. There is no 100%. We can give a certain amount of confidence. That's all. And we will go with that certain amount of confidence.